this is the second part of free response question 1 on the first AP Chem exam. It asks you how you would determine the empirical formula. Or, sorry, explain how you determine the empirical formula of the copper iodide. And the interesting part of this is explain. Not find the empirical formula, explain how you would determine it. So basically what we know is that empirical formula is the ratio of iodine to copper. So, and it's by mole. So this is part 1b. So moles of iodine to moles of copper, that's the empirical formula. So what you would do is divide by the smallest. It doesn't really matter if you say that you would take moles of copper to moles of iodine. Now, ultimately, in a ratio like this, you're going to turn one of these numbers into a 1. But all you have to say in 1b is that you would take the ratio of the moles of iodine or copper, doesn't matter. We'll say moles of copper to moles of iodine is the empirical formula. So if it's 2 to 1, then it would be CuI2. If it's 1 to 1, then it would be CuI. And if you wanted to include an example, you could, but you didn't have to. So if you said moles of copper to moles of I, and it was, we'll say, let's go with 1 to 2, then the empirical formula equals CuI2. Let's look at 1c. It says, explain how each of the following would affect the empirical formula could be calculated. So what that means is that they're probably going to affect the empirical formula. So don't just say it would affect the empirical formula. They know that. They want to know how. So if we look at 1c1, it says some unreacted iodine condensed on the strip. So that means originally there's more iodine used than I think. So if that's true, that would make the mass of this compound, the mass of the copper strip and compound, too high. So therefore, if you compare Cu to I, when you do mole to mole, this number would be too high. Therefore, the empirical formula will be off. So the way you phrase that in a sentence is, if some reacted iodine was condensed on the strip, then there would be more mass of the compound, which would yield to a calculation of more moles of iodine than were actually used, which would then make the I value in the empirical formula too high. So, for example, if you were supposed to get 1 to 1, you might instead get 1 to 2 or 1 to 3. For 1C2, it says, a small amount of the white compound flaked off before weighing. So here's my strip with the compound, and that has a certain mass, but now I actually have less. So the mass of the compound is less than it should be. So what that means is, in your empirical formula, Cu to I, if the compound is less, that means the moles of I is too low. So if the moles of I are too low, your empirical formula is going to be off. If it's supposed to be 1 to 1, you might see 1 to 0.7. If it's supposed to be 1 to 2, you might see 1 to 1 instead. So these are opposite problems. Just make sure you explain them in a sentence.